everyone, my name is Alessandro Giampieri from Durham Energy Institute, and today I'm gonna talk about hydrogen-fueled cars and trucks. In the first slide, a comparison of the emissions, energy consumption and driving characteristic of conventional and low-carbon vehicles is reported. It is clear from the figure how low-carbon vehicles such as battery electric and hydrogen-fueled ones are able to reduce emissions and energy consumption of the transportation sector at the expense of a shorter driving range. Hydrogen can be used in cars and trucks in both fuel cell vehicles and internal combustion engine ones. The main properties of hydrogen, together with those of methane and gasoline, are reported here in the table, and this characteristic would affect the hydrogen transportation in terms of storage, optimal combustion and safety. Here in the slide, the hydrogen supply chain for on-road transportation is shown, the main components of which are hydrogen production, storage and distribution. And in addition to that, for on-road transportation, hydrogen refueling station and onboard storage are fundamental components. As said, hydrogen refueling stations are one of the key elements of the automotive hydrogen supply chain, and the main factors for its development are the technology used for hydrogen production and distribution, and also for onboard hydrogen storage, together with the hydrogen demand. Currently, a limited number of hydrogen refueling stations are available in the UK, less than 20, and with a limited production capacity, which in most of the cases is lower than 100 kg per day of hydrogen. For the future rollout of hydrogen transportation is required the development of a larger refueling infrastructure with the development of hydrogen refueling station with large capacity up to 2000 kg of hydrogen per day, and also an optimization of the capital and operating costs. The low energy density by volume of hydrogen represents an issue for its storage on board the vehicle. Here in the slide, the main technologies for hydrogen storage are represented, from the more conventional ones such as compressed and liquid hydrogen up to the more innovative ones such as metal and chemical hydrides. The choice of the onboard storage technology will affect not only the requirements in terms of pressure, temperature and refueling station typology, but also the energy density that can be achieved, the cost and the safety. In this slide, the powertrain of hydrogen-fueled cars is shown. For fuel cell electric vehicle, a proton exchange membrane fuel cell is used with a power output higher than 60 kW. The hydrogen storage technology is hydrogen compressed up to 700 bar by using high pressure composite vessels type 4. This technological solution, however, could create problems in terms of safety and location availability in the vehicle. For internal combustion engine cars, different options have been tried for the internal combustion engine, such as port fuel injection and direct injection spark ignition. Current technological solution, however, cannot combine high performance, low emissions and high durability, and such further research is required for hydrogen-fueled internal combustion engines. For the hydrogen storage technology is similar to that used in fuel cell electric vehicles. However, an additional issue is created by the high injection pressure that is required. The main challenges of hydrogen-fueled cars regard the decrease of their cost in terms of all the components of the hydrogen supply chain, such as hydrogen production, distribution, storage and onboard storage, but also a decrease of the fuel cell cost for fuel cell electric vehicles in terms of a decrease of the cost of their materials such as membrane, catalysts and so on, and optimized manufacturing. Also, it is required an increase in the performance and in the safety, together with the development of standards and of the refueling infrastructure. In this slide, a comparison of the main characteristics of battery electric and hydrogen-fueled cars are reported. While battery electric vehicles represent a mature and well-developed technology, their short driving range and long recharging time represent an issue that could limit their marketability. On the contrary, the characteristic of long driving range and short refueling time of fuel cell electric vehicles is very promising for their use in passenger vehicles. However, the current high capital cost and the lack of refueling infrastructure is still limiting its use. For hydrogen-fueled internal combustion engine cars, they could be seen as an intermediate solution towards the realization of hydrogen transportation, because of their cheaper costs and their higher flexibility. However, more research should be conducted on the hydrogen-fueled internal combustion engine to increase its efficiency and to reduce its NOx emissions. As such, the market of hydrogen-fueled cars is still quite limited and will develop further in the next decade. Compared to cars, higher scope is identified for trucks because of the large emissions of the conventional diesel-powered trucks, and also because of low manufacturing volumes are required, meaning that there will be a less difference in capital cost between hydrogen-fueled trucks and conventional diesel ones, and also for the need of high energy density, short refueling times, and high longevity that could suit hydrogen-fueled trucks that are seen as the most promising low-carbon alternative to diesel-powered trucks, particularly for long-distance trucks. In this slide, the powertrain of hydrogen-fueled trucks is shown. For fuel cell trucks, again, a proton exchange membrane fuel cell is used with a larger power output that can range from 295 kW fuel cell used in the Hyundai model up to a 350 kW fuel cell used in every vehicles. For the hydrogen storage technology, compressed hydrogen at 350 bar is conventionally used, and compared to cars, the larger volumes of trucks allow for more flexibility in the choice of the location of the hydrogen storage. For hydrogen combustion engines trucks, dual-fuel hydrogen diesel are seen as the most promising and cost-effective technological solution. It was identified that by adding hydrogen to conventional diesel-powered engine, it's possible to increase the performance and the efficiency of the engine and to reduce the emissions. Dual-fuel hydrogen diesel trucks require little or no changes at all to the engine, and they are able to operate with different blend ratio hydrogen diesel, and in case of necessity to operate with only diesel. The challenges of hydrogen fuel trucks are similar to those of hydrogen fuel cars. However, more interest is given to an increase of the vehicle durability and an optimization of the utilization of hydrogen refueling stations. In this slide, a comparison of battery electric and hydrogen fuel trucks is reported. The low energy density, heavy weight and long refueling time of battery electric truck is a problem that limits their use in particularly long distance trucks. On the contrary, hydrogen fuel trucks are a very promising technology, particularly because of their long driving range and short refueling time. In the short and medium term, high scope is identified for the development and use of hydrogen diesel dual fuel long distance trucks. In the last slide, the main conclusions are summarized. As seen, the potential of using hydrogen in cars and trucks to decarbonize the transportation sector is high. However, the current challenges in terms of cost reduction of all the components of the hydrogen supply chain, increase of the performance and development of safety standards and the refueling infrastructure are required to further increase their marketability and public acceptance. And thank you for your attention.